There may be life on Venus, or at least a complex molecule, and scientists don't know how it got there. Meanwhile, a 3 gigapixel camera for a remote telescope in Chile will enable high-resolution images of the nighttime sky with some stunning detail. And Australia's former Defence Minister Christopher Pyne joins a list of scientists and defence experts calling on the UN to create a space treaty to avoid exploitation of resources in the solar system. It's Wednesday, September 16, 2020. I'm Matt Miller at Trekzone HQ. Dr. Brad Tucker is standing by with those stories of the week, plus the headlines, right after this.
Beaming around the world with the latest science and space news on Facebook Watch, YouTube, and wherever you get your podcasts. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
He's back with us. It's another Wednesday. It's another Talkin Science. Dr. Brad Tucker. Happy Wednesday.
Yeah, an exciting week full of cool announcements.
It is very cool. I got your email this morning. Some very cool stories coming up this week, from great discoveries to some serious issues that need to be contended with. It's certainly going to be a very interesting show.
That's right. You know, it's the whole gamut of space.
And of course, we can find you on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook. I'm on Twitter at Miramat86, and of course Trekzone all over social media. Just search for Trekzone. Brad, without any further ado, let us get into the show.
Talking Science headlines.
And first up, Brad, this week in our headlines, evidence for a new meteorite crater has been discovered just north of the mining town in Western Australia of Kalgoorlie.
Yeah, it's believed to be quite a big, relatively big impact. You know, something where the impact is about 5 kilometers. This is much bigger than some of the other famous craters in Australia, like Wolf Creek, believed to be, you know, on order of 100 million years. So, you know, not anything related to dinosaurs wiping out, but definitely just shows there, you know, there's a lot of these things out there. And by looking underneath the ground, you find a lot of evidence of impacts, especially in places like Australia or even Antarctica.
Now, this one, the Ora Banda crater, as you say, looking underground, experts were using electromagnetic surveys to map the rocks and discovered it, as you say, bigger than Wolf Creek, which is pretty impressive.
It's one of these things we're trying to piece together, finding the meteorite impacts, finding the meteorites themselves and tracing it back, something new projects are trying to do. It's quite an interesting study to connect that whole process.
Now, meanwhile, the Australian Space Agency has opened its supply chain grants for the Moon to Mars initiative.
Yeah, this was part of this pledge for $150 million to participate in the NASA Artemis mission and give groups a chance to develop useful space infrastructure, patents, technologies, spin-offs that can then be used to participate in the Moon to Mars mission from the US. And so kind of a way to fuel the industry here and also kind of have a dedicated or clear supplier or end user overseas who may use that or purchase that. So it's nice to see that's moving.
Prospective candidates have until June 2023 to make an application for anywhere up to $1 million. So not small change, certainly worthy of an effort and a fundamental goal of getting to the Moon and Mars.
Yeah, and it really trying to fuel having partners work together, develop it, you know, and enough money to develop that prototype or whatever that may push someone over the line to get it into a full working state.
And moving up to the Gold Coast, Gilmour Space Technologies has announced Space Machines Company as their first Australian commercial launch customer. This is pretty cool.
Yeah, you know, Gilmour Space, which has kind of been led by Adam Gilmour and co, trying to develop sovereign rocket capability, launching capability in Australia. So super exciting that they have that customer and they're seeing the end of the tunnel and having a rocket launch in a year or two.
Talking Science, stories of the week.
Brad, diving into the meat of our show now, and this one is very cool. Announced yesterday, phosphine has been discovered in the atmosphere of Venus.
Look, this is it's quite exciting for a lot of reasons. You know, Mars gets lots of the attention for potentially being a good place to host life or look for life. Early on, though, there was always lots of wondering, looking, examining whether Venus was that place. Venus is often called Earth's twin, or, you know, sometimes ugly twin or evil twin. And the discovery of phosphine, phosphine being phosphorus, and hydrogen is quite interesting because this paper goes through a lot of great detail, and there's a lot of credit from the community of how much work they put into this paper to rule out all possibilities. And they end up at the conclusion that the source of whatever is producing this is unknown. And there's a few different cases or a few different options for which could be producing this phosphine, one of them which could be a biological process.
That is very, very cool to think that somewhere as harsh as Venus could potentially have life, but not necessarily on the planet's surface. They're thinking it might be in the atmosphere.
Yeah, the detection is about 50 to 60 kilometers up in the atmosphere. Now, when we think of Venus, it has a very dense atmosphere. It's 95 or 96% carbon dioxide, and it rains sulfuric acid. It's runaway greenhouse effect. It's 462 degrees every single day. It's just kind of a terrible place. There's nothing great about Venus for the most part. It is harsh. The type of life we have here on Earth, we just don't think it could survive Venus. However, as you go up into the upper atmosphere of Venus, so just as in Earth, as you go up, the temperature decreases. So at 40 kilometers or 50 kilometers in our atmosphere, it's, minus 40, 50 degrees Celsius, if not colder. In Venus, as you rise up, the temperature gets balmier, so to speak. It gets cooler and therefore gets a tad more manageable. And everyone said that if you were to find evidence of life, it would be in the upper atmosphere where the conditions are not as harsh and therefore maybe a bit more palatable or a bit more able to survive or support life.
Now, Brad, it is a mysterious gas, as you say, produced with a couple of elements. Brad, how are these microbes surviving in the upper atmosphere? Are they just kind of hanging out in the clouds, or have they built little cloud cities like in Bespin?
This is not even a conclusive of life. There obviously could be some sort of unknown process that has created this, geochemistry or planetary-wise, something not life, but obviously if it's microbes, it would be exciting. And again, this is thought to be microbes we're talking about, bacteria, simple things. And we do know of microbes that produce phosphine on Earth, which is again one of the reasons why they have arrived at one of the potential conclusions of this. There's a lot of questions about how they could be surviving up there, whether they migrated up there, they evolved up there. But if they are up there, again, if this is from life, they have to be pretty tough because they have to have built a hardy shell or life or environment to survive the harsh conditions. So, as some people pointed out, how do they eat or feed or get energy or whatever you may want to call it? How do they live and not just survive? And I think that becomes quite an interesting question. Whatever this is, it's a very interesting idea to put into perspective what we know about Venus.
We have to quantify that and say we don't know what this is. If it is life, it is remarkable. But even if it isn't life and it's a chemical process that we don't yet understand, that's incredible as well.
Yeah, look, this is obviously an exciting step into Venus. And I was drawing this parallel. I think it's similar to Mars. We've seen, for instance, things like varying methane on Mars. And lots of processes have been ruled out. And it still could be some sort of Earth or Mars, rather, some ground geochemical process. Or it could be a biological process. Again, life forms give off methane. Just think of cows, right? Apparently penguins get off phosphine. So, we know these things. But again, it could just be an interesting part of the planetary system that we just don't know. And as we try and understand how planets live, how planets survive, how planets evolve, especially as we put Venus in the context of Earth and Mars, it tells us interesting things about that planet and therefore how planets evolve. So either way, definitely an exciting thing into understanding more about our solar system.
Brad, are we going in the wrong direction for looking for life in our solar system?
The Russians looked at Venus early on, and the problem with Venus is the harsh conditions just destroy probes. They just don't survive long. And that was always one of the tricks is how do they manage getting there? There are new missions being talked about to go to Venus in maybe the 2030s. And I think we'll see this happening as we talked about, as space travel and exploration becomes cheaper. You can now look at different places. And I think this will help push the case to not just give up on Mars. And either way, if it's biological, if it's just planetary or chemistry or geology, it'll be interesting to study not just Mars, but also Venus as well, because they're very different stages or very different types of planets or planetary evolution.
Alrighty, Brad. Next up, a Gigapixel camera has taken a photo of broccoli to prove that it works. Now, this is very interesting, but it has some real-world applications as well.
Yeah, this camera was built for the Vera Rubin Observatory, which is being built in Chile. And this is a telescope that will be 8 and a bit meters wide and to try and survey the sky every couple of days. In order to see lots of area, you need a gigantic camera. And so they built now what should be the world's largest digital camera at 3.2 gigapixels. So that's 3.2 billion pixels. A lot bigger than what you have on your mobile phone.
The mobile phone is only 16 megapixels. So to think that there's 3,200 of these suckers in this telescope, I think that means that we're going to get a pretty good level of detail on the nighttime sky and be able to survey a lot of it a little bit quicker.
Yeah, this is trying to see lots of area and also at the same time, lots of depth. So it's kind of just like on your TV, right? The more pixels you have, the more things you can see, but also the clearer picture you can get. This is exactly what they're trying to do here, is to see as much as they can, as possibly as they can. And I think it's super exciting. This project's been in the works. Similar groups work together to build a camera I use, which is called the dark energy camera, which was relatively smaller, still hundreds of millions of pixels. I remember when we built our telescope Sky Mapper at Siding Spring and we clocked in at 268 megapixels. That was big at that time, 7-8 years ago. And these things just get bigger and bigger, allowing us to see more and more.
Now, there's a 10-year mission for this camera and this telescope to survey its entire field of view every few nights, as I said, for 10 years. That is going to produce a wealth of data that is going to take more than 10 years or even more than 20 years for astronomers to study.
That's right. And this was this project, and there's a lot of these telescopes that are happening. Instead of saying, all right, we're going to build one telescope, and then, astronomer A goes look at their star, astronomer B goes look at their galaxy, and so on. We're going to build bigger telescopes and combine our resources and just have these things that can automatically scan the sky all the time. So everyone gets to see their objects. We get to have lots of data. We get to look at things that change with time or things that move in position. We get to look at lots of different colors. You get to combine a wealth of data set that you wouldn't normally be able to do. And it allows reducing the risk of weather problems and interference. You don't have to necessarily travel to the telescope to observe, so that saves on effort and energy. So these are becoming very efficient things, these robotic telescopes.
Now, this one's going to be interesting because being such a wide field of view, snapping the sky every few nights, as we've talked about, these satellite mega constellations that are going up with Starlink, OneWeb, and all these other companies, they could potentially ruin the images coming from the telescope.
This telescope in particular, the Vera Rubin Observatory, has been in the calculations of being affected by Starlink and as you said, others. And it could be something like 30 to 40% of the images are lost because of what is there in the sky with the satellites. And then that's a lot for a very big, expensive project that when it was built and planning, this thing has been over, decade plus in the making, closer to 2 decades, really. A lot of it will be lost. And these are the issues with these mega constellations is critical science and infrastructure that is built for very good reasons and trying to be efficient is lost. And you can't just do this in space. It doesn't really work like that. A, you can't build this big of a telescope. B, the cost times in that are just not even comparable. And so these are some of these real issues that need to be mitigated so we don't just waste 40% of a 3.2 billion pixel camera.
That is a big percentage to lose out, and OneWeb's more of a concern for the telescope because it has a higher altitude, which means it's going to stay in the field of view for longer than Starlink satellites.
That's right. The longer it's in the field of view, the more it's blocking and interfering. We're used to having satellites in our images. This is not something astronomers are unique to, but it's different from when you have one small streak through part of your camera versus 80 or 100 streaks across the entire camera. You just waste that image. You can't really do much with it. And that really affects the science you can do.
Well, it is expected that it'll start snapping the night sky as opposed to heads of broccoli in late 2022.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
And Brad, last up this week, Christopher Pyne. I've missed him. I've missed being able to imitate him. Christopher Pyne is joining scientists and other security experts to call for a multilateral space treaty, if you will.
Look, and it's quite interesting that it was Pyne that has joined this. And this is something that, I know quite a few other people, scientists, and really there's a lot of space policy and space lawyers who signed this, and quite a few colleagues here in Australia. And this is something, people have been trying to push for, is we need to really get control of these issues in space now before it's too late.
And the growing concern here is that there's potentially a new space race on the way between China and the US.
We see it, we know it's happening. And it's the thing, it's a bit different than the space race in the 60s when these treaties, like the Outer Space Treaty and Moon Treaty, were signed. There was a race. No one really knew what was going to happen clearly in the step. Obviously, there was a lot of worry of militarization, missiles, nuclear bombs, all those sorts of things. Here, everyone sees the writing on the wall, and that is getting to places like the moon, asteroids, other places, claiming land, extracting resources, mining it, and the potential conflicts that arise. Again, not too dissimilar, if we mentioned this before, to what's happened or what could have happened in Antarctica. And people are trying to say, look, the writing's on the wall. We all see what's going to happen. We all even talk about what's going to happen. So let's just do something so that doesn't happen.
And there's also a bit of a rhetoric change as well. You've got a president in the White House that's pushing for all of this, and he signed an executive order earlier this year stating that America had the right to explore and use these resources in outer space. So I guess the sort of change from the 60s is that we can now get further for longer and more often. So we can support these mining missions to the moon, to Mars, to asteroids, compared to the 60s when we were just trying to get into orbit.
Yeah, that's right. These things aren't far-fetched. And we have the added complication that it's not just the countries or national agencies or governments that can do this, but the private companies as well. And as you said, with that executive order, it was really clear not just about NASA's goals, but the private companies in them. And look, this goes back to a law Congress passed a few years ago. Luxembourg has passed laws circumventing treaties. It's a messy thing. It obviously goes back to enforcement, which is another tricky element. And this is why this statement is kind of important. It's from a cross-section of people, including former defense ministers in Australia, saying, look, we see these issues. We know these issues. The UN, you really have to step up the game. Yes, you're doing something, but there needs to be more rapidly, but before it's too late. And it's not this kind of doom and gloom or threat. It's just the reality of the situation.
And Christopher Pyne is saying that the United Nations should play the role here in brokering this peace treaty, for lack of a better word, space treaty, peace treaty. That's really what the United Nations is there for. Hopefully they can get some heads together around a table and really bash out a deal.
That's right, that lots of people can agree with and work on and want. And I think that's the trick here, is can we get life together, so to speak, in a way that works for everyone.
And as you alluded to earlier, it's not without precedent. The Antarctic Treaty of 1959 is protecting the continent down there from exploitive mining operations.
And this is kind of why there is a bit of hope. We look to places like Antarctica and say, look, hey, we've done this before. Surely we can do it again. If we look in Antarctica, groups like the US, Russia, China, all relatively work together. And so it is possible. And this is the push, is let's make it possible.
What I love about these sort of arrangements is that they just work. And when you take the politics out of it and it's just scientists are happy people. They're loving people. They get together and they just get in and get the job done. When it becomes politics, it's the upper levels that sort of have the issues. It's a little bit like, for me, in television, it's, you have the television wars and the rival networks and stuff like that. But boots on the ground, There is no rivalry. It's just getting the job done. Very similar here with scientific discovery and the Antarctic missions, space missions as well. I've been watching Netflix's Away, where there's a lot of international rivalry. It just really doesn't sort of exist at the ground level, does it? It really is up there in the political offices.
That's exactly right. And, it is trying to say, look, we all just kind of want the same thing. And even that, we understand that there's going to need to be some resource extraction in space. And it's not actually saying that's not the case. But there are clear ways and oversights that can happen to make it sustainable, safe, logical, all these little things, so we don't end up in a mess. And that's what it's really trying to say is we all want the same thing. We all want to work together. Let's just do it while we can.
Exactly right. Well, a great way to end this week's Talkin' Science, Brad. Thanks very much for checking in and diving into the stories of the week. We'll catch you again next week.
Sounds good.